Okay. Hey, there we go. All right. Substitute Dragos. Cole. What happened to the real Dragos? What's going on? Cole, Carter, Demios. Hey, there's the real Dragos. What's up? Hey, Aaron. All right. Let's do this. So, I believe Monday feels like so long ago. I can't even remember if I announced the course eval incentive. I think I thought I did, but I don't remember. But anyway, maybe that was in 312 I did. I know I did for one course. Anyway, here's the course eval incentive. If I said this on Monday, apparently I didn't because it says updated 1 day ago. Maybe I didn't post this on Monday. So if it's the first time or if it's a reminder, whatever, I'm going to go through it. So the course eval incentive, the only information I get is the response rate. So my incentive is based on response rate only. I can't base it on anything else. So if the response rate hits 60%, I'm going to open up application objectives at each percentage threshold. At 60%, I'm going to open up genetic algorithm again, AO1 and AO2. You can complete those again. These do not apply to any lecture tasks. The lecture tasks for all three of these homeworks are completely done. Nobody's working on those anymore. At 60%, I'm opening up AO1, AO2 for genetic algorithm. 70%, I'm opening up point of sale, which I think point of sale is the biggest one that people both need, like haven't completed yet, and is within reach. Like the genetic algorithm AOs are pretty tough. But this is the big one. Hopefully we can get to 70% so you can get those AOs. And then at 80%, I'll open up pale blue dot. I think most students who are still in the course, who haven't fallen off or failing one of the learning objectives, I think most of the students who are in the course still have these already, but if we hit 80%, I'll open those ones up as well. So I'll open those up until the last day of class, midnight, December 10th, right before midnight, and you can continue to work on those application objectives. So if you're looking at what I did, I did say this because I was talking about the final exam. So if we get these incentive thresholds, get these opened up, and you don't feel like coming to the final exam, work on the application objectives, get your 6. And of course the homework 4, those are still open until the last day of class just naturally because we haven't hit that checkpoint yet. Get your 6 out of these 8 and then skip the exam. That's completely within your right. I'm keeping the response rate. I keep updating this, which I'm going to update right now. This is the only thing I get to see is this screen right here. I get to see these 3 percentages for my 3 courses. For 116, we're at 46%, and nothing to update. So we're at 46%. That is current. I've been checking this throughout the day, throughout each day. Whenever I need a quick mental break, I go to the evaluation center, hit refresh, and then I update for the 3 courses. So 46%, we're starting to get to that 60%. As we reach each threshold, I'll go to AutoLab and I'll update the due date for each homework assignment and update it to December 10th as we hit the threshold. So once we hit a threshold and you see that update, and I'll put a message on there, this incentive unlocked, whatever, and I'll update it in AutoLab. This does not open it up. I said this already, but I actually got this question. I'm surprised I even got this question, but it does not unlock the lecture tasks. If that applies to anyone in here, you're probably not in the room, but it does not apply to lecture tasks, even though the deadline's going to change. I have this problem all the time. Once someone sees the deadline in AutoLab, they assume that means they can do complete everything after that deadline, which is not true, at least not in this class. Like, with all the way extensions work and everything, I don't know. Creates confusion sometimes. So anyway, that's that. Fill out your course evals. I put the link right here. Super convenient. Click on that link and get there. I don't have much else to say about that. If you're waiting for these incentives, bug your friends, bug your classmates. Be like, fill that thing out so we can get these incentives. And let's go back to this, what to do for review. Post that I made in lecture 11 days ago before the break. And let's knock out some more of these things. So there's still not too much. There's both not much posted here, and at the same time there's everything posted here. So I talked about this on Monday. I'll talk about this a little bit more either this Friday or next week. I'll go more in depth with more details as we get closer to the final exam. This I talked about. This is handled. This is handled. This we did on Monday. And then here are the new posts. There's not much here. Like these last two posts didn't get any upvotes, so it's just each of those is literally one student in the class saying, let's cover this. So I'll still do that. I mean, 1 is greater than 0, so that's what I'll do is whatever somebody's asking for over nobody. And the other one, state patterns, I've actually prepared a little bit for this one because, hey, we got 3 upvotes. 4 students in the class actually want this. 4 out of 248, hey, I'll take it. I'll consider that a lot given the situation because a lot of y'all just are not using this post. So whatever, I'll take it. Oh man, I'm way behind on chat. Is there anything I should know in here? Is this all off topic? Yeah, this is definitely off topic. So let's talk about state pattern. So state pattern, just a quick refresher on the state pattern itself. I'm going to go to the state pattern of jumper. I'll go to the most complex example that we saw because you all should be fairly familiar with the state pattern. So a quick refresher on the complicated part that we saw. We applied this in the jumper game where we have a character that can navigate a platformer game. So we have physics and everything. And what we wanted to control with the state pattern is the behavior of the character. How is the character going to interact with the world based on different states that the character can be in? So we have the buttons that you can press, left, right, up, down, left, right, and up. There was no down. Left, right, and up. And those buttons will have different behavior depending on the current state of the player. And they'll have significantly different behavior. So we want to capture that through the state pattern by saying, depending on the current state of the player, what state is it in? Is the player standing on a platform, walking on a platform, falling down in the air, rising in the air, or these extra states that we added for the double jumps? We want the player to behave differently in each of these states depending on the buttons that they're pressing. So we drew up this state diagram. Let me go to the simplified one, actually. We don't need the extra states in there. So we have these states that the player can be in, and the buttons that you press will be different, will have different behavior based on them. So then in each state, we can define the behavior that the player will have in that specific state. So if the player's standing on a platform, for example, and the player hits the up button, that player is going to jump a certain amount. If they're walking on a platform, they're going to be in the walking state, and they hit the jump button, they're going to jump at a higher height. We want a higher height if they have a running jump than if they just jump from a standstill. And common in platformers, you're going to jump higher if you have momentum. You're carrying that momentum through the air. And what behavior are we going to have if we're rising or falling? If we're in the air and the jump button's pressed before we implement double jump, that shouldn't do anything. So we're basically disabling that button. The left and right buttons still work. You can still change direction mid-air in this game. But if you're in the air, rising or falling, you're going to be, your momentum, your speed is going to be less. You're going to carry less momentum if you try to turn around mid-air. You might have a nice velocity moving through the air. If you want to turn around, we're going to limit that. We're not going to give you full versatility in this game. So in those states, the buttons have different behavior depending on what we want, whatever we want. So it's a way of capturing the different states that the player can be in and then implementing the behavior in each one of those states based on whatever we want to happen. So when we go to write this code, when we're writing, for example, the falling state, we're hyper-focused on the behavior in that state and in that state alone. So how should the player behave while they're falling? And while we're writing that code, we're not worrying about anything else. We're not worrying about how they behave when they're walking, standing, rising, or in game over. We're just saying what happens when you hit the up button while the player's falling. And we expanded this a little bit for double jump. Well, maybe we do want you to be able to hit the up button and jump while you're rising or falling. And when you do that, you're going to get a second jump, and then transition to a state where you've already used your double jump, and now the jump button is deactivated. So we're allowing one double jump and then triggering a state transition after that double jump is used to disable the jump button after that and not allow triple jumps or quadruple jumps or whatever. You only get one double jump. What am I avoiding? Cults and mortality rates? I mean, I guess I'm going to avoid those. How many students left in 116, aka survivors? Oh, there was an actual question there. I thought you were talking about literal mortality rates. That's why I brushed it off as off topic. How many students survive? It's usually bad. It's pretty bad. It's looking like 60% will survive this semester, which is actually better than history dictates. So there's that, but not great. Jesse the executioner. I mean, it's been closer to 50. It's even been less than 50 in certain semesters. It's a tough one. It's a rough one. The rate in 115 isn't as bad. It's usually I have to invert all my numbers because I'm used to thinking about failure rates. About 70%-ish, I believe, is about their number past 115. And then next semester, it's usually worse than 116, which puts me in a dilemma where, out of the 60% that pass this semester, historically speaking, close to 50% of those students will fail next semester, 220, 250. Which puts me in a dilemma brings up the interesting question. I don't even know if I should say this, but I'm going to anyway because I don't care. But should I fail more students because a good portion of the students that I'm passing are still failing next semester? Should I allow that? Is that, and let me rephrase that. Is that doing you a disservice if you're going to fail next semester, get 2 Fs and 220, 250? Am I doing you a disservice by letting you squeak by with a C and giving you an extra extension when you probably shouldn't really have it? I go through those dilemmas. Somebody who just barely gets through 116 is, realistically, you got to retake 116 to be able to get this material so you can then move on successfully. But if I let you pass, I shouldn't say let you pass. If I give you that next extension and you end up passing, and then you get to 220, 250 and you just can't do anything because you don't know the background that you're supposed to know, you're not going to go back and retake. Most students, most humans, wouldn't go back to 116 and retake 116 voluntarily. So you're going to take 220, 250, fail, retake 220, 250, fail, retake 220, 250, and I don't know, maybe pass. Some students do end up passing on like a second or third or sometimes fourth. They have to get a waiver for that retake. And then maybe pass. I don't know. So I think a lot about this kind of stuff. I'm happy to be passing as much as 60%, but, I don't know if I'm doing a disservice or not. A lot of the structure of the course is trying to prevent you from moving on and getting in that state where you're going to be stuck in a cycle of failing 220, 250 over and over, and eventually changing majors is what those students end up doing. Either changing majors or just dropping out of college. So I don't know what the real answer is. I've been leaning towards being more lenient and letting you prove yourself next semester. But just be warned if, any of you, the takeaway here is make sure you understand the content of this course before jumping into 220, 250, or even just one of those courses if you're only taking one at a time. make sure you know your background material. If you're still struggling on these assignments, if you can't go back to the 116 assignments and really knock them out after the fact, you got some studying to do over the winter break to really be prepared for 220, 250. And this is, I always recommend this. This is because, you might not believe me for a variety of reasons. This is a good thing to ask the TAs in office hours. They've been through 220, 250, or some of them are in it right now. Ask them. Ask them what the jump is from 116 to 220, 250, because there's definitely a jump from 115 to 116. There's a pretty decent jump there. In my opinion, I think the jump from 116 to 220 plus 250, because you're taking two courses, or I guess to be fair, 191 plus 116 to 220, 250, I think that jump is significant. I think that's probably the biggest jump in our whole curriculum. It's a good increase in difficulty. It's because at that point, they assume you know how to code. They assume you know all the content in 115, 116, because you should if you passed. And they're just going to hit the throttle and go. They're going to teach you the next stuff, the next layer of computer science. And if you're still struggling to put a method together and combine your loops and conditionals and things like that, if you're still struggling with that and you just brute force through the homeworks in 115 and 116, those students don't make it through 220, 250. Unless, you just become unless you revise all of your study habits and just become a completely different student in your approach to your courses. That's really what it takes if you've been brute forcing your way through these courses. So, a word of caution, I don't know what the answers are. I'm constantly trying to revise the structure of my courses to be able to address that. That's how I got to where 116 is now with the learning objectives. You have to know all this stuff before you can move on. I'm trying to be very direct in that. This is the stuff you need to know. These 3 bullet points on each of these 4 learning objectives, this is what you need, and I'm going to grade you directly on that. I cut out all the middle stuff of grades and percentages and all that stuff, cut out all of that and just said directly, this is what I need you to know, or else you're not going to succeed next semester. So I made that as direct as possible, so hopefully that's coming across clear through the structure of this course, but I know there's still a lot of work to do. I think, I don't know what the next step is, but of how to revise the course further, but anyway. It's not what I expected to talk about, but this is open to whatever you want to talk about, so I'm happy with that. Yeah, 220s in C and 250s in Scala. 250s in Scala, so you have a whole semester of Scala. 250 used to be a lot harder, by the way. I'm fine talking about this the whole lecture, by the way. This might be more valuable than rehashing specific content. If y'all have questions about this. 250 used to be a lot harder than it is now. It is actually a little bit easier, in my opinion, because 250 used to introduce C++. We would have 2 semesters of Java, and then 250 was in C++. So 115 and 116 were both in Java. And you were trying to learn a new language on top of all of the 250 content, all these new data structures and writing proofs about data structures, analyzing their runtime and everything. And that was a lot. That never really went well with students. I think part of it is just because of C++ being the way it is. But we changed that around so you're not learning a new language in 250. But then in 220, we're introducing C. So you are learning a new language in 220, and you're using 2 different languages in either of your courses. You're using Scala in 250 and C in 220. So if you're taking them both at the same time, you have to constantly switch between those languages. And 220 is going to show you a lot of low-level stuff. It's going to be all the memory diagrams that we did in this course. It's going to be that times 10. It's going to be that most of the semester, understanding exactly how memory works. I kind of briefly showed you how doubles are represented in 64 bits and their truncation errors. You're going to dive way deep into the details, talking about the difference between the mantis and the exponent and the IEEE format of what exactly each one of those bits of those 64 bits represent, things like that. You're going to really talk about the low-level details of how things run in the computer. We did very brief, not very brief, we focused on it quite a bit, but stack and heap and references, we talk about that. It's that, but hashing out all of those details, where we kind of gloss over things at a pretty high level. It's the stacks over here, the heaps over here, and there can be references to things on the heap. Like that, in a nutshell, that kind of sums up what we talked about in memory management. 220 is like all of the details, like all the details. And then 250 is a lot more data structures, but it introduces proofs. 250 is supposed to be an extension of 191. I still think there's a little bit of a disconnect there, but it's going to be proofs and coding, all related to data structures. So your math background is going to come in. I think that's what gets students most in 250 is the proofs. We showed I won't even call it a proof, but I showed like the outline of a proof when I talked about the runtime of merge sort, and I showed that the runtime of merge sort is n log n. That's the kind of flavor of things you'll see in 250, actually proving mathematically that the runtime of merge sort is O of n log n, and proving that, like with somewhat the style that you use in 191, but actually applied to real stuff. Like in 191, it's like prove these two equations are the same. You're never going to do that in real life. In 250, it's, okay, we have this algorithm, analyze its runtime, and also prove that it's correct. Prove that merge sort actually does sort values, mathematically, prove that. That's the kind of stuff you'll do in 250. And also coding. It's supposed to be 2/3 coding and 1/3 proofs is the balance that by design we have, but I don't know in practice exactly what they're hitting in 250 these days. Maybe a TA can chime in on that one. In 220, you invert the heap. I'm fine with 220, 250 stuff in the regular lecture channel, if it's questions for me, if it's stuff I should see. I'd be happy. Like this these whole 2 weeks is, like I'm literally saying, it's whatever you want to see. So if I just react to chat, if somebody posts here and says, why don't you just react to chat for a whole lecture, I can do that. Fine with that. Because only, a maximum of 6 people have even made suggestions for what to see here, and there are more than 6 people chatting right now. If that's how you want to recommend stuff. Jesse, what do I think of teaching 199? I mean, I wouldn't mind it, but it seems like just logistics and stuff. I don't think I'll be on that course. I gotta be a little careful how I word things because I don't want to give the wrong impression. But there are enough faculty members who want to teach 199, and I don't really want to. Like I wouldn't if the department said, "Hey, you're teaching 199 this semester," I'd be like, "Yeah, whatever." But it's not something where I'm like, "I want to teach 199," and there are a group of faculty who do. So I'm probably just never going to be on the course. I'm pretty comfortable. I have 116, obviously, and CSE 312 web applications. I'm pretty happy teaching those 2 courses. Those are the ones that I always tell the department, I just want to teach these 2 courses. I'm happy with these. If I have to teach something else, I'll do it, but these are the ones that I want to teach. So if I get my perfect version of the future, I'll just be on those 2 courses. I'm basically saying 191 is boring. No, I'm not saying that. That's why I have to be careful the way I say that. 191 is not boring. It's more that I've been teaching 116 for a few semesters now. I've been teaching it long enough that I'm in a good rhythm. Like I know how the course rolls, and just switching to a different course. I've never taught 191 before. So switching to a different course, there's a lot of setup costs and getting in the flow of the material and things that I wouldn't mind it. I wouldn't mind it if they said, you're teaching 191 for the next 3 years. I'd be like, okay, I can do this. But if they're like, this one semester you're teaching 191, like that's a pain in the ass. That's just a lot of extra work. Yeah, 116 kind of is my baby. Was he saying 191 or 199? 191. I was on 199 for a while. You might be the first student. No, it's fall semester right now, isn't it? Yeah, but you might be the first students who haven't had me in 199. I finally got off of that. Well, let me not word it like that. But this is the first semester that I'm not on 199. Uh, 220 will be code heavy. And I don't believe there's any required testing. This is something that I hope I got across this semester, but I fear that I don't in this course, the way it's structured. This is one thing I want to fix. I don't believe there's any required testing in 220. I might be wrong on that, TAs. Am I right or wrong on that?
When I took it, no required testing,
Okay.
but it does throw curveballs at you.
Yeah. So in 220, and I know what those curveballs are. I just didn't know if you ever graded your tests at all or made you rate tested. So no required testing in 220. Like you're not going to have your testing graded. Testing, the way it stands right now, is a 116 topic. Like this is the semester where I'm showing you what testing is and hopefully getting across the value of testing. If you write good tests first, your code is a lot easier to write because you can run your tests against your code. In 220, it's not going to be like that. You'll have the auto grader. You'll be able to submit, and it'll give you a partial score, the way it's set up right now and the way it'll probably be set up next semester. The auto grader will give you a partial score, so you can at least know if like things are compiling right, you have things set up right, and the auto grader can see, read your code and interpret it properly. Then after the deadline, there's going to be a new grader uploaded, the full grader, and that's going to be run on your code, and that's going to give you your actual grade. So you don't get the full feedback before the deadline. So if you're not testing your code, when that new grader is uploaded, you're just going to have to hope that you have the correct functionality there. So if you're not testing your code, you're probably going to do pretty poorly in 220. So hopefully in 116 you've gotten the idea that testing is a good thing, I hope. Because if you don't, students who don't test after 116, a lot of students don't test. I even see it in 312 still, students don't write tests. You're going to spend a lot more time on the assignments than you have to. If you're testing and running the debugger I tried to stress, I showed it in lecture quite often. Testing and running the debugger, if you're not doing those two things in your courses moving forward, you can still get through the courses. Like students have proven that you can brute force through the entire curriculum, but you're going to have a lot more free time if you embrace those two ideas, testing and debugging, actually running the debugger. In C, learn GDB, learn that thing and get familiar with it. If you've still been brute forcing through 116, you're going to brute force the rest of the time. Yeah, you can still get to graduation, but you're going to spend a lot more time than you have to on every assignment. And in my opinion, you won't be as strong of a developer when you get out to industry. If you can get 10 hours of work done in a full 40-hour week, you're not as valuable out there in industry either, because you're just going to take so long brute forcing everything out there on your actual job too. So the earlier you can learn that lesson, part of the reason I'm saying this is because I learned this lesson a bit too late and I wasted a lot of freaking time. But once I finally started using the debugger, it was eye-opening how much easier things got. And I wasted a lot of time. So it's more of a word of caution, like don't be like me. Learn it right now, freshman year, or second semester, I should say. Not necessarily freshman. But second semester, learn that lesson, run that debugger, do your testing, and it might seem like more work at first to write your tests, especially when you're not forced to, but it saves you so much time, so much time. Can you break Autolab? Depends what you mean by that. mean, there are ways to break Autolab. It's pretty robust, at least my graders are pretty robust, but like I would be able to break it knowing how it all works, but it's tough to do. Yeah, it depends what you mean by that. And Ruslan is right with that's explicitly in the AI policy for the course, trying to break the auto grader. But I've had students who finished the assignment and then talked to me and said, I want to try to break it. Go for it. As long as you already did the assignment properly, and then you want to just play around and try to break Autolab, I'm okay with that. I'd appreciate if you let me know first, because if I catch you before you let me know, that can be problems. But if you let me know first, be like, hey, I just want to try some things. All I need to know. That's all you heard was yes. If they succeed in breaking Autolab, just give them the A. Well, you have to still do you still have to complete the learning objectives to get the A. But I've had students who broke Autolab, and I hired them as TAs. Some of my best TAs, I shouldn't say that, but I hired TAs. I hired them as TAs whom I then hired to work on the Autolab project itself. And several of them are still working on the Autolab project and maintaining that. So if you want to break Autolab and you're interested in that stuff, we can talk. Didn't Jesse offer at one point if you exploit Ubuntu image to give full points? I mean, I might have said that. It depends what you mean by that. I need more context. All right, there's one more thing I do want to talk about. I don't want to, I'd be happy to just interact with chat. And if you want to raise your hand and shout out too. But there's one thing I want to talk about to finish this one up. I'll talk about these two briefly just now. This one, I don't really know what to do with this because it's saying literally go over all of LO3. If you can narrow that down a little bit or be a little more specific in some way. But with no upvotes, it's tough to spend the time to go over that took me 3 weeks to go over. And you have all those lectures. So what out of that 3 weeks do you want me to talk about? You literally just listed all of the topics. So if you can help me out and know exactly what you want. This one is a little more focused, saying just recursion. I did cover this a lot too, so if you can be more specific, and especially, if it got more upvotes, I would go over all of LO3. If somebody's review the whole course and it got 100 upvotes, I'm reviewing the whole course. But with 0 upvotes, it's tough to know what to do with those. This one, I do want to talk a little bit more about this one. So we reviewed what the state pattern is. So we want different behavior based on the state of something. We're putting all the behavior of each state in a separate class. The second part of that was an application, various applications of it. So I do have an application here I want to share. Oh, WebStorm, why do you do that? And I'm going to try to get the code in here without explaining too much of what's going on here. This is a game, it's a tower defense game where you and all the other players are defending a tower from wave after wave of zombies, and then your tower has a certain amount of hit points. Once your tower dies, it's game over, and your goal is to survive all of the waves and defeat all the zombies throughout all these waves. So the way I have this coded to be able to work on this, I have my top level class, the class that contains all of the logic of the game. The whole game is in this one class, objects of this type. I have all kinds of game stuff, all kinds of stuff happening in here. The one I want to highlight right here is on update. So I have this game running. My brother and I are working on this. So my brother and I have this game running at Autosave interval, timeout, autosave interval, somewhere in here. Updates per second, start game loop. When there's this much code, you forget where things are. Oops. Find usage. 50 for some reason. 50. Let me just change that to 60 right now. I don't know why we have that at 50. So we're going to start the game loop. And I just broke something there. So we're going to start the game loop at 60 frames per second. So update is called 60 times per second. We got a 60 FPS game running. For some reason it was set to 50. I don't know. Maybe my brother was testing something. Maybe I did it. I don't know. And every frame, we call that, just for those of you not familiar with games, just a very brief terminology. So 60 updates per second, and each update we call a frame. So each frame update, which happens 60 times per second, we're going to call this onUpdate method with the amount of time that passed since the last frame was updated. And then instead of doing anything in the game itself, I'm embracing the state pattern. I'm saying, well, I want really different things to happen on a frame update depending on the current state of the game. So I'm going to defer to my state. I'm going to have this loop state variable and tell it to update and let it control all of the actual logic of how the game should be updated on this specific frame. What should happen this frame? And then I have my state pattern set up here in a separate directory. I always like to put my states in a separate directory. I have my loop state, which would be an abstract class. This is JavaScript using Node, so the setups are a little bit different at times. But I have my loop state with some constructor that just initializes things. I'm storing the game in a state variable, so I always have a reference to the game. So I can call the game utility functions as I'm moving through. And then the big update method. My API is really small here. It's just the update method. And every loop state needs to implement that update method that takes the amount of time that passed since the last frame update and do whatever it's going to do. So in the abstract class, I'm going to do a lot of updates. If the game is in a cooldown state, I'm going to tick down its cooldown timer. Each object has a cooldown timer on each of its abilities. I'm going to tick those down if the cooldown timer is running, so you can't spam your abilities. I'm going to update a lot of fields. These are fields for AI movement. I'm going to check if any characters, any game objects have 0 HP, anything that is alive that died has HP. All those checks are like, I don't want a tree to die, even though a tree has 0 HP. Trees are just static. So if it has HP, et cetera, then kill it, et cetera. Tell the AI engine to do its thing. Tell the physics engine to do its thing. Check for weird situations. I love this check. It hasn't found anything weird in a while, but I like having that there just as a peace of mind. And then broadcast the game state to all the clients. All the clients are connected via WebSockets, as it turns out. I don't always use WebSockets, but for this app, I happen to. Broadcast that to all the players and say, here's the update for this frame. Then all the clients update their UI so everybody can see all the updates. So that's the abstract class, or what we've been calling, at least what I call in this course, an abstract class. But it is a full class here. And then for each class, for each state that the game can be in, and the game initializes in the loop state initial. So loop state initial is going to extend loop state. And it's going to do whatever the game needs to update in this initial state. The initial state, it's only one frame. It's a one-frame state where I'm just initializing everything. I'm creating the base, adding that to the game, and just setting up whatever I need to set up. This is placing the base into the game. if there is an object that happens to be at the location where I'm trying to place the base, put the base in one of the neighboring locations. So just very little stuff, and I could add to this if there's more things I need to initialize. This is where I'm going to put it. That's going to update one frame, and then switch to have a state transition to the loop state new game. So once we have a new game, I'm going to set a cooldown timer, 5 seconds in this case, and then in 5 seconds the game's going to start. So this is where we get like a countdown, 5, 4, 3, 2, 1. I broadcast the game will begin in however many seconds. And I'm going to set all of the HP for the players in the base. All players start at full health. Base starts at full health. So this state can be reached after a game over. So after a game over, I want to restore all the players to full health. So I'm going to do that here. Then switch to the loop state between waves. While this is ticking down, nothing happens. But once the timer reaches 0, that's when we do all this stuff and then switch states. Now, at the end of each state's update, I'm going to call super.update. And this is a common thing in most languages, have this keyword super, which is going to access the superclass or the class that we inherited from, that we extended. The class that we extended is going to be super. So I'm going to say, do all the stuff that we need to do in new game, in the new game state, and then also call the superclass's update method. So all of this logic that we have in loop state, which is going to do the AI and the physics and everything, all that stuff I want to happen on each update. So I'm overriding the update method, but I'm also calling the update method from the superclass, from that abstract class. So I want both sets of behavior. I'm just adding extra behavior onto the superclass's behavior. We're going to state transition to between waves. We start another countdown timer, which is in a variable. Then I'm going to count down. Once that countdown timer hits 0, we're going to start that wave. I'm going to get all the monsters for that wave, place them into the game, and then transition to the running wave. So now the zombies are there. We're at full health. We started the game. The zombies are all placed. They're about to attack us. Wave 1 begins. We have a running wave, so we transition to a different state. And now in this state, I want to be checking things. We're in the middle of a wave, so I want to be checking a couple of things. Are all the zombies dead? Or is the base destroyed? Those are the two big things I want to check while a wave is running. So I'm going to check how many enemies are remaining. If there are no enemies left, we're going to the next wave, and we're transitioning back to the loop state that's between waves. That's going to reset the between waves counter, and it's going to count down again to initialize wave 2. Some updates. Updating the fields for the AI movement. I'm not getting into the details of that. And then checking the base. If the base health is less than or equal to 0, well, game over. We're going to transition to that game over state. Game over is going to say, sorry you lost, and then go back to the new game state. And if neither of those conditions are met, we're just going to keep going, again calling super.update. And if we hit the game over state, game over does nothing. It kills all the zombies. I had this is one of them bugs that you find through testing is we would lose the game, but I wasn't killing all the enemies. So a new game would start, but it'd have all the enemies that just killed us, plus the wave 1 enemies for the new game. And I'm like, well, we can't have that. So I had to kill all the enemies that are on or everything that's on the board. It used to kill just enemies, but we have summons as well. You can summon little helpers and stuff. We need to kill them too. Game over, and we transition back to a new game. So this state, it's another one-frame state, mostly involved with killing all the things. Oh, I have that in the constructor. I could have that in the update. And if I want to add things, this doesn't do much in update. But when I want to add things, like this is where I might have player stats. This is where someday we'll have player stats, and I'll I'll write to the database and say these players have updated their win-loss ratios, their kill counts, and things like that, their accuracy. All that kind of stuff would be updated right here, right on the game over. And I think that's all the states. So this is an application of the state pattern where I have a game, it's got different states, and I want the game to behave very differently based on which state we're in. And I don't necessarily want, oh, I do have it now, but yeah, I remember when I added that. New game maybe? No, I do call super.update. But super.update has all the AI, the physics and stuff. There are cases where I might not want that to be called. So I might want to just not have this call, not have all the updates going. Maybe when I'm at the title screen, there'll be a title screen state at some point. And maybe I don't want any physics updated while we're on the title screen because that doesn't make sense. I just don't call this. So it gives me the chance to have very different behavior depending on the state of the game. Are we waiting for a new wave to start? Are we in the middle of a wave? Are we waiting for a new game to start? Are we in the lobby waiting for new players to join? Which obviously that last state I don't have. Someday we'll have it. But whatever the state of the game is in, I want to encapsulate that and keep each one of these files as concise as possible. When we're between waves, what needs to happen? Well, I have a countdown timer, so I'm going to put that countdown timer logic here, and once the timer hits 0, I'm going to start the next wave. It helps me focus. Like I don't have to think about how the entire mechanics of the entire game work when I'm writing just that piece of functionality. So it helps keep things focused, clean, whenever you have, and specifically whenever you have something that has very different behavior depending on what's going on in the world. If I'm starting a new game in the lobby, between waves, during waves, after a game over, these are very different sets of behavior you want from any game, of course this game, but any game. Your game is going to behave very differently in each of those states. So this is a way to, the state pattern is a clear application, a clear contender for the solution here. Throw the state pattern on there and get that very, very different behavior by splitting that functionality that varies based on the state. And notice there's a lot of functionality that doesn't vary based on the state. All that I'm going to put in my game class, and then just how things update on a frame, that changes significantly depending on the state. So that's the functionality that I'm deferring to a state for. The rest of the functionality can stay in the game class. It's not going to change based on the state. Most of it's just helper methods and how to actually store the state of the game and send that to other players. None of that stuff's going to change based on what state we're in. So I don't use the state pattern for that. Is the zombie game finished? No. And I'm sad that I can't even show a demo. I'm not set up to do a demo right now. We had to move the server, unplug it and plug it back in, and a few days ago, and I didn't fire up the server again and fire everything up. But if I can set that up, I can show it off on Friday, if I remember. All right, so that takes care of that one. I have these two. I mean, these are the only two suggestions left besides the final exam that I'll get back around to. So if there's something else you want to see, use this post. That's my way of knowing. Like, this is the only way for me to know something ahead of time, so I have a chance to prepare anything. Like, I could pull up that code and be ready to talk about it for today's lecture because we have at least a few upvotes here. So if you want to see something else, use this post. I'm checking it every day, especially before each lecture. And, we're right at 2:40, so see you Friday.